Hi, I'm Teruji from the Global Priorities Institute, and I'm going to be talking about the paper I've been working on, which will be called something like The Asymmetry, Uncertainty, and the Long Term. So, how bad would it be if life on Earth went extinct, let's say within the next century? It could be a huge asteroid that crashes into the Earth and wipes everything out, or there are other scenarios having to do with climate change or biotechnology. Lots of scenarios we could consider. I'm going to focus on the impact that extinction would have on people, but of course other things might matter as well. So one thing that would happen is about 8 billion people would be killed. Another thing that would happen, though, is that there wouldn't be any future people. Now, how many future people wouldn't there be? Well, it depends, of course, but it's not that hard to tell a story on which there might be 10 to the 16th, or perhaps vastly more future people if things go smoothly. And what's striking is that the second consideration is, at least potentially, a lot more important than the first one. So, going just by total welfare, let's say, a 1 in a million chance of 10 to the 16th extra lives might easily be worth all of the welfare of all of the people currently alive. Now, one idea that's popular among economists and pretty unpopular among philosophers is that we should simply exponentially discount the welfare of future generations. And that's not a debate I'm going to talk about. I want to talk about a different idea. And the idea is that even though we may very well have an obligation to improve the lives of present and future people, we simply don't have a similar obligation or requirement to increase the number of future people, for example, by preventing extinction. And more precisely, a lot of people are, at least initially, attracted to something like the following idea, which is called the asymmetry. So suppose we have a choice between, on the one hand, a status quo, creating no one, and on the other hand, creating a lot of people, some additional people. And if we create the additional people, that will have no effect on the people who independently exist. Then first of all, if the additional people would certainly have bad lives, we ought not to create them. But second, if the additional people would certainly have good lives, it's permissible, but not required to create them. So if this is right, that would mean that the second consideration against extinction would not really be important. It would be the first consideration that would really matter. Now, it may help to say a little bit about the motivation behind this idea. Suppose we create someone who we know will have a bad life. Then, in some sense, that person is our victim. Right? They have a complaint about what we did. On the other hand, if, in the second case, we simply don't create someone who would, hypothetically, have had a good life, then there is no victim, and there's no one who has a complaint about what we did. So that's usually how this idea is understood. Now, the problem is that the asymmetry is just one principle, it's not a complete theory. And there are very few next to no theories of the asymmetry that are well worked out to the extent that we could do any kind of serious analysis, for example, plugging this theory into an economic model or something like that. And in particular, when we think about any remotely realistic sort of choice, it becomes crucial how we think about uncertainty or risk. And none of the existing theories of the asymmetry say anything really about that. So my main goal here is to get some better theories of the asymmetry on the table that deal with risk in a plausible way. And along the way, I want to make it clearer what kind of principles we might rely on and what kinds of problems and choice points arise along the way. So first I'm going to introduce you to some of the problem cases that we can use to guide our thinking about the asymmetry. In this first case, which I call mixed addition, there are two options, Act 1 and Act 2. And in all of these examples, you should think of Adam as being essentially the current generation, and Eve, Cain, and Abel are potential future people. So in the first option, Act 1, Adam alone exists, and he has a pretty good life, represented by the number 10. In Act 2, we create Eve, Cain, and Abel, and Eve and Cain also have pretty good lives, but Abel has a slightly bad life, represented by -1. Now, some theories of the asymmetry are going to say that we ought to choose Act 1. Why is that? Well, remember what I was saying just now about the motivation involving victims or complaints. If we look here, Abel has a complaint about Act 2. He has a bad life. However, in Act 1, no one has any complaint, right? So on that basis, it looks like we ought to choose Act 1 rather than Act 2. And if that's right, then there's at least a heuristic here that we ought to positively encourage extinction. And that's because if we don't go extinct, then there will inevitably be some bad lives in the future. And at least as far as this example goes, it looks like we should prevent those lives from coming into existence. But I don't think that's really compelling. And Joshua Gert has a useful idea here, a distinction between reasons that require us to do something and reasons that merely justify us in doing that thing. And I think it's fairly plausible here that the fact that Eve and Cain would have good lives in the second option, even though that can't require us to choose Act 2, might well justify us in choosing Act 2. The fact that Eve and Cain would have good lives can render Act 2 permissible. Anyway, that's one example to think about. Here's a second case which has a similar structure. Here in Act 2 we create Eve, Cain and Abel with good lives, all of them. But this comes at some cost to Adam. He gets 9 instead of 10. Now again, if we think about complaints or victims, we can see that Adam has a complaint about Act 2, and no one has a complaint about Act 1. So again, that's how you might argue for a verdict, that we ought to choose Act 1 over Act 2. So even if it's permissible to create future people, it would be impermissible to do so at any cost to the current generation. That's a hard verdict, but you might think, in light of what I was saying before, that in fact the soft verdict is the correct one, that in a choice like this, either option is permissible. Again, after all, if the fact that Eve, Cain and Abel have good lives if that fact can justify us in creating some people with bad lives, then it should also perhaps justify us in imposing some kind of cost on the current generation. Now we come to a third problem, which is, I think, thornier. This is the famous non-identity problem. The asymmetry is mostly about increasing the numbers of future people, but we should also ask about improving their lives. And there are lots of different things that can fall under the vague heading of improving lives. So for one thing, we can keep the people the same, but make their lives better. That's one way of improving lives. But another thing is to make different people who happen to have better lives. And as Derek Parfit influentially argued, in the long run, we tend to do the latter thing. Most of the things that we do will have some eventually quite wide-ranging effect on the identities of future people. So, for example, consider case 3. Here in Act 1, I have Adam, Eve, Cain and Abel. Eve, Cain and Abel have slightly good lives. And in Act 2, I replace them by 3 different people, Eve prime, Cain prime, and Abel prime. Now, of course, if we were going by total welfare, then we ought to choose Act 2 over Act 1. That's what I call the wide verdict. But if you thought about complaints, you might instead think that you ought to choose Act 1 over Act 2. And that's because, again, Adam has a complaint against Act 2. He's worse off than he could have been. Whereas when we look at Act 1, no one has any complaints. Adam, Eve, Cain and Abel, they all have good lives and none of them could have been better off. So that's how you would argue for this narrow verdict that you ought to choose Act 1. There's no victim. Okay, so it might look like endorsing this narrow verdict would greatly undermine the importance of improving the lives of future people, insofar as these improvements tend to change the identities of future people. Now that is true to some extent, but there are some subtleties here. So in the previous case, Eve, Cain and Abel had good lives, and there was an option of replacing them with better lives. Here, Eve, Cain and Abel all have slightly bad ones, and again we can replace them with different people with good lives. All kinds of views are liable to say that here we ought to choose Act 2 over Act 1. And that's because even though Adam still has a complaint against Act 2, here Eve, Cain and Abel all have complaints against Act 1, insofar as they have bad lives. And that consideration could easily outweigh Adam's complaint. Right? So all kinds of views are likely to recognize the importance of some kinds of ways of improving the lives of future people, here by replacing bad lives with good ones. Now we come to a fourth issue, which is the thorniest of all, and I don't have time to say much about it today. And the problem is that the asymmetry strongly suggests that this relation ought to choose x over y, it's a relation between options, is not a transitive relation. And that raises all kinds of issues related to decision theory. Now, in the written version of the paper, I suggest that one might borrow Condorcet methods from voting theory in order to deal with some of these issues. The idea there is that there are structurally similar kinds of intransitivities that arise in voting theory from the so-called Condorcet or voting paradox. So there might be some ideas that we can borrow from voting theory there. For today, I'm just going to sidestep all of these issues by focusing on two option choices. Right? For two option choices, the issue of intransitivity just doesn't arise. However, I will note that the standard way of thinking about choice under uncertainty, namely expected utility theory, does presuppose transitivity. And as a result, there's not going to be at least any completely straightforward application of expected utility theory in the context of the asymmetry. So how should we think about risky choices? That's what I want to talk about next. All right, so the plan here, I'm going to give some general principles that enable us to reduce arbitrary, risky choices to risk-free choices. So given these principles, all that remains to be done is to write down a theory of the asymmetry in risk-free cases. I call these principles supervenience principles. Supervenience is a piece of philosophical jargon. All it means here is that these principles specify conditions under which we ought to treat one choice, for example between A and B, the same way as a second choice between C and D. So what that means is, if we ought to choose A over B, then likewise we ought to choose C over D. And if we ought to choose B over A, then likewise we ought to choose D over C. And that's what the supervenience principles are doing. Here's the first one, which I call person-wise supervenience. It goes like this, and I'll give an example in a minute. Suppose that for each person, P, and each pair of welfare levels, X and Y, and these can include non-existence, the probability that P would get X under the first option and Y under the second option is the same in each of these two choices. So the probability that P would get X under A but Y under B is the same as the probability that P would get X under C but Y under D. Okay. So if that condition holds, then the principle says that we ought to treat a choice between A and B the same as a choice between C and D. So here's an example. Here's how it works. Here in the first row I have acts A and B, so that's the first choice. In the second row I have acts C and D, that's the second choice. Now when I look here, I'm flipping a fair coin. H is heads and T is tails, so the columns here correspond to different outcomes of the coin toss. And in Act A, if the coin lands heads, then Adam gets X. Whereas in Act B, if the coin lands heads, then Adam gets Y. So there's a 50% chance that Adam gets X under the first act and Y under the second act. And similarly, a 50% chance that Adam gets Z under the first act and W under the second act. Now, when we look at the choice between C and D, all I've done is I've switched the roles of the two states, heads and tails, from Adam's point of view. So it's now on tails that he gets either X or Y, and it's now on heads that he gets either Z or W. But it's still true that there's a 50% chance that Adam gets X under the first act and Y under the second. And it's still true that there's a 50% chance that Adam gets Z under the first act and W under the second. So the person-wise supervenience principle says that switching around the payoffs in these ways makes no difference to which of the two options we ought to choose. Now, because people often ask about this, let me point out, I'm not saying that if we merely switch around x and z here, that wouldn't make a difference to which option we ought to choose. I'm switching around x and z, but at the same time, I'm switching around y and w. So this preserves the point that it's still in the same state, here heads and here tails, that Adam gets x or y. And here it's tails where Adam gets x or y. Okay. The second principle, which I call state-wise supervenience, has a similar flavor. So now suppose that in each state, for example heads or tails, and for each pair of welfare levels, the number of people who would get x under the first act, but y under the second act, is the same in the two choices. Then the principle says that we ought to choose a choice from A and B the same way as a choice from C and D. All right, let me illustrate that again. So here I'm focusing on a specific state, heads. So on heads, in the first pair of options, there's one person who gets x in the first act, rather than y in the second act. And there's one person who gets u in the first act, rather than v in the second act. And down here, in the choice between C and D, that's still true. I've just switched the roles of the two people. So here, there's still one person who gets x rather than y. Now it's Eve rather than Adam. And there's still one person who gets u rather than v. Now it's Adam rather than Eve. And the state-wise supervenience principle says that switching around the payoffs in this way doesn't make any difference to what we ought to choose. Okay. The third principle is called scale invariance. And it says this: suppose that the first choice is just a scaled up version of the second choice. And by that I mean it involves more people, but they have the same pattern of interests. Then we ought to treat a choice between A and B the same way as a choice between C and D. And that will become clear from this illustration. Here, when we look at C and D, I just have Adam. Okay? And in the first choice between A and B, I've introduced Eve, who's basically a clone of Adam. Her interests are perfectly aligned with his, and that's what I mean by scaling up. Okay? Here I've scaled up by a factor of 2, but we could scale up by a greater factor as well. And the scale invariance principle says that scaling up in this way makes no difference to which of the two options we ought to choose. All right. So there's obviously a lot more to say about these three principles, to defend them and explain why they might be true. But I have to skip to the main result here, which I call the supervenience theorem. And it says, given these three principles that I've just been describing, a theory of risky choices is completely determined by its restriction to risk-free cases. So if I spell out what the theory says in risk-free cases, then that will automatically determine what you ought to do in risky cases as well. All right. So I'm going to start by giving you two basic examples here. These two basic examples have nothing to do with the asymmetry, and then I will sketch out the third example in more detail. So this is just to give you the hang of it. So suppose that you maximize total welfare in risk-free cases. All right? Suppose that's your view about risk-free cases. Then the upshot of the theorem is that in risky cases you maximize expected total welfare. So that's a form of total utilitarianism. Suppose, on the other hand, for a second example, that you maximize average welfare in risk-free cases. Then the upshot of the theorem is that in risky cases you maximize this ratio, expected total welfare divided by the expected number of people. Okay, so that's a form of average utilitarianism. But notice that this thing here, this ratio, isn't the expected average welfare. And in fact, it's not the expected anything. So this is an example of how these principles are compatible with and even lead to violations of expected utility theory. All right? Now, the third example, I'm going to sketch out how these principles could be combined with a theory of the asymmetry. And I don't really expect you to absorb all of the details here. You'd have to look at the written version to completely understand what's going on. The main thing that I want to get across is that this is genuinely possible and not altogether difficult. So in thinking this through, we should remember some of the choice points that I identified early on in the talk. We should think about what to say in costly addition cases. That was the hard-soft distinction in case 2. And we should think about what to say about non-identity cases. That was the narrow-wide distinction in case 3. And for today, I'm going to focus on a wide, hard view. That's probably the most popular type of view. And remember here that wide means that we generally are required to improve lives, even in non-identity cases. Hard means that we shouldn't do costly addition. That is, we shouldn't create additional people if that imposes a cost on independently existing people. And I'm also going to allow for mixed addition. That is, we are in some cases permitted to create a mixture of good and bad lives if we do so costlessly. Okay, that was the first case that I considered. So how would such a view work? Well, suppose we're given 2 outcomes, A and B. This is the risk-free version. These are risk-free outcomes. And let's suppose that there are more people in option A, okay? Or at least as many people, I should say. So what should we think about when making a choice between these 2 options? First of all, we should look at the necessary people. And by that, I just mean the people who exist in both of the options. So there's some number of necessary people, and they have some total welfare in each of the 2 options. Then there are the other people, the contingent people, the people who exist only in A or only in B. And there's some number of them, and with some total welfare in each of the 2 options. Now, because I said that there are more people, or at least as many people in A, that means that there's some excess number of people in A. And of course, it's not that some particular people are the excess people, it's just some excess number of people. And there's a natural way of dividing up this total welfare of the contingent people, attributing some of it to the excess people in A, and the rest of it to the non-excess number of people. So divided up in that way. Then this is how the view goes. To choose between these 2 options, we should weigh up 3 things. First of all, the effect on the necessary people in terms of their total welfare. Second, the effect on the non-excess number of contingent people in terms of their total welfare. And third, if the excess people in A would have bad lives, then we ought to take that into account as well. All right, so you just kind of add up those three terms. Now that's a view, I said, when A and B don't involve any uncertainty. Now we plug this view into the theorem, and it spits out a view of risky choices as well. And in fact, the general view with risk is formally the same, except whenever I talked about the number or the total welfare of necessary or contingent people, we should just use their expected number or their expected total welfare. So it's a fairly straightforward generalization of the original risk-free view. Okay, so I wish I had some more time to show you some examples of this theory that I've just sketched in action. But I hope I've at least made it a bit clearer to you what it might take to write down a theory of variable population, risky choices that's compatible with the asymmetry. Okay, so just to recap a bit, I propose these supervenience principles that allow us to reduce risky choices to risk-free choices. Second, I briefly mentioned the idea of borrowing some Condorcet methods from voting theory in order to deal with intransitivity. And third, given all that, all we have to do is write down a theory of risk-free pairwise, that is, 2-option choices, like this wide hard view that I was talking about at the end. I will also draw one relatively practical takeaway of all this. It may seem like the asymmetry tends to undermine the importance of the long-run future. And of course that's true in some sense, but as I suggested, many views are actually going to demand sacrifices on the current generation in order to improve the lives of future people in particular ways. And as I suggested, one kind of intervention that will be supported by a great many views will be interventions that are aimed at reducing the number and severity of bad future lives. Thank you very much.